6.5. Today we're going to be doing the sine law. So we're going to switch gears in this chapter. Lessons 1 through 3 are dealing with right triangles only and the coordinate grid. And then 5.5 and 5.6 deal with what situations where we do not have a right triangle. So we're going to apply something called the sine law. So I'll talk about what the sine law is, and we'll solve problems involving triangles that are not right triangles. So these triangles we have today will not have a 90-degree angle. We're going to skip the whole first section of the getting started here and move right to the bottom of the second page where it actually tells us what the sine law is. So the sine law applies to all triangles. And what it says is, I'm going to draw a triangle here so we can visualize it. When we label a triangle, we usually use capital letters for the angles. So let's say we have a triangle ABC. We would use capital letters to refer to the angles. And the opposite side, like so for example, let's look at angle A here. The side opposite to angle A would be called little a. So little a refers to like that entire side length there, whereas the big A would refer to the angle. Okay, so this would be called A. This would be called B because it's across from angle B, and this side would be labeled side C because it's across from side C. So again, these little letters are referring to the entire side length, whereas the big letters are referring to the angles. Okay, so now that we know how to label a triangle, let's look at what the sine law says. So I'm going to use the highlighting colors here. So it says the ratio A divided by sine A, so this length A divided by sine of A is equal to the ratio between B and sine B. So B being that whole length there, divided by sine B. And that's also equal to C divided by sine C. Okay. So we can use the sine law to figure out missing sides and missing angles. You can also flip it around and say sine A divided by little a is equal to sine B divided by little b, and that's equal to sine C divided by little c. It actually doesn't matter which way you use it. It's the same thing. Okay, great. So that's the sine law. We're now going to apply it to some scenarios. Okay, so in check your understanding number 1, we're going to use it to find out a side length. We're given a triangle here. They use different letters instead of A, B, and C, but it's the same idea. So I'm just going to use my highlighter again to label. So what we know in the sine law is the side length divided by the sine of the angle. That ratio is going to be equal no matter what side I'm looking at. So it's going to be equal to this angle on this side and the sine of this angle and this side. Okay, so we're always looking at like sides that are directly across from the angles. So let's see what this question is asking us to do. It says determine the length of GH. That's the same as J here. G to H would be J. So we want to find J. Let's see what we have. So we do have angle G and we also have side G. We don't have angle H and we don't have the side length of H, but we do have the angle J. So you have to think critically when you're using the sine law and figure out which sides you need to use. So in this case, since we know a lot about G, we're going to use G. So let's write down the sine law for G. So sine of angle G over length G is going to be equal to sine of angle J over the side length J. Now we do have this information and we do have this angle, but we don't know J. This is what we're trying to find out. Okay, so let's fill in what we do know. So angle G is the sine of 51 degrees divided by 7.8 centimeters equals, so that's the blue ones. Now again, we're not using green here because we don't know anything about the green lengths. So you don't need to use the entire sine law, you just need to use the parts that you do have the information about. And we do know that angle J is 44, but we don't know sine length J, that's what we're trying to find. Okay, so we have an equation here. We're going to use algebra to solve it. And when you have two fractions that are equal to each other, you can use what's called cross multiplying to solve. So you multiply the two terms that are diagonally across from each other that you know and divide by the third term. So you multiply these two terms and you divide by the remaining term. So J is going to be sine 44 times 7.8 centimeters divided by sine 51. And that is something you can just type straight into your calculator. Make sure you're in degree mode. So sine 44 times 7.8 divided by sine 51. And you should get, make sure you check yours with mine, 6.972 dot, dot, dot. So it's a decimal number, it's irrational. And the question says to round it to the nearest tenth of a centimeter. The side length J would be about 7.2. I'll put a little squiggly to say we've rounded it. Centimeters there. Okay, there we go. So that's how you use the sine law to calculate a missing side. We're going to do one more example where we use the sine law to calculate a missing angle, and that'll be the lesson. So we're going to do check your understanding number 2 now. Let's label what I know. So remember, we're focusing on, so this one it says find angle N. We want to find this angle. Let's highlight here what I've got. And angle P. Okay, we have to think really critically when we're doing the sine law. So I'm definitely going to use M and little m because I know both the angle and the side length there. So I'm going to use that. I want to eventually find angle N, which is labeled in pink here, but I'm not going to do it just yet because I don't know the side length across from it. So if I tried to set up my equation like that, sine m over m equals sine n over n, I could try, but I don't know either of these two things in pink. So I cannot solve that equation as is. So what I'm going to do first is find the green angle, P, and then find the pink angle from there. Can't do this. Since we don't know, oops, can't spell no today, n or little n. Okay, so let's set it up like this instead. Sine m over m equals sine p over p. So m is 92. So this is the blue and the green here we're looking at. And length m is 11.8 centimeters. It's the blue one. Sine p, we don't know angle p, so we'll just leave that blank. And little p is 10.0 centimeters. Okay, now we're going to solve for this. Okay, so remember you multiply the terms that are diagonally across from each other that you know, and then you divide by the other term. So sine p is sine 92 times 10.0 divided by 11.8. Let's see what we get. So that would give us sine 92 times 10.0 divided by 11.8. I'm going to write down the whole decimal here. 846941370. So to get the actual angle P, I need to take the inverse sine of that decimal, and I get approximately, so you can just leave it in your calculator and use the answer if you like. I get approximately, let's see what they want us to round to, nearest degree. So I get about 58 degrees. Now, that's not the final answer yet because I didn't need P, but I'm going to use it now to find N. So what I know is that all the angles in the triangle must add to 180. So if I know that one is 92 and one is 58, I can now find angle N. So angle N would be approximately 180. Ooh, that went weird. Minus 58, the one I just found, minus, what was the other one, 92. And that would be approximately 30 degrees. Okay, great. So sometimes using the sine law, you'll have to be a little bit strategic and find something else before you get to your final answer, because you don't know either of the terms in the part that you need. Okay, so that's an example of the first example, just as a quick review. We found a missing side, and then the second example, we found a missing angle. And that's the end of the lesson. The other examples are just applications, and you can try those on your own if you like.